Hey guys, hello everyone and welcome to my channel Chem Fact. Today in this video I will be talking about isolable analogy. I will mainly focus on the concept and its application. I will also tell how to determine if two fragments are isolable or not. So without wasting any further time, let's go to the main video. The isolable analogy is the concept used in organometallic chemistry to relate the structure of organic and inorganic molecular fragments and to predict the bonding property of organometallic compounds. It was Nobel laureate Roald Hoffmann who first coined the term isolable analogy, and he developed this concept. He says that two cluster fragments are isolable if they have similar symmetry, similar number of electron in cluster formation, and appropriate same energy. And this will be clear from some example. So, in the above question, we see that what in CH3, NH2, OH, FCl, and the two complexes, what they have in common. In CH3, carbon has 4 valence electrons and each hydrogen have 1 electron. So CH3 has total of 7 valence electron. Similarly in NH2, nitrogen have 5 and each hydrogen carries 1. So NH2 as a whole carries a total of 7 valence electrons. Similarly in OH it also has 7 electrons. And for the complexes, cobalt complex or the molybdenum complex, we can calculate the total valence electron. In the cobalt complex, cobalt has 9 electron and each carbon monoxide fragments give 2 electrons each. So the cobalt complex has total of 17 electrons. Similarly, the molybdenum complex also has 17 electrons, and these fragments have one thing is common, that is they all have 7 electrons or 17 electrons, that is they are isolable. The valence electrons are same, and as the valence electrons are same, they can be replace each other in the complex structure. We can tell that two fragments have same number of valence electrons, they can be considered as isolable, and this can be easily seen from the table. In CH4, carbon has 4 valence electrons and each hydrogen carries 1. So 4 hydrogen carries as a total of 4 electrons, and CH4 unit has a total of 4 plus 4 equal to 8 number of valence electrons. In nickel complex, nickel has 10 valence electrons and each CO ligand gives 2. So there are 4 CO ligands. So as a whole it has 8 electrons, and the total valence electrons of the nickel complex is 18. Similarly in CH3 minus, carbon has 4 valence electrons, each hydrogen carries 1, and here 3 hydrogen is present, so 3 and 1 is for the negative charge, so it has also 8 electrons. And we can see that CH4 and CH3 minus have 8 electrons, whereas nickel complex has 18 electrons. But from the organometallics we see that 18 electron complexes are as stable as the main group elements having octet fill up. So these are, so we can clearly say that these are similar in energy, and so they are isolable. And from the rest of the table we can also say that the CH3, the cobalt complex, and CH2 minus are isolable. Similarly CH2, the ferric complex, and CH3 plus. So we can safely say that if two fragments have same number of valence electrons, they can be considered isolable. The isolable analogy allows to relate the compare organic and inorganic and organometallic complex compounds on uniform basis. Hydrogen, boron, and carbon have 1, 3, and 4 valence electrons respectively. So each BH unit have total 4 valence electrons, that is 3 for boron and 1 for hydrogen. So it has a total of 4 valence electrons, and each carbon atoms have also 4 valence electrons. So in structure of boranes, If we replace a BH unit that carries 4 valence electrons by a carbon which also carries 4 valence electrons, the structure will be stable or the complex will be stable. So we can replace the BH unit from the boron structure by carbon, and this results the formation of carborane. These are the basic principles of isolobal analogy. I hope you guys can understand the concept and apply this.